All right, this is section 3.2, and we are going to do a quick review of logarithms. So if you recall, if b to the x is equal to y, then log base b of y equals x. So in number 1, this would be 5 to the second power is 25. 9 to the 1/2 power is 3. B to the a is x. So the big idea here is the base is the base. The answer to the logarithm is the exponent in exponential form. So this is log base 2 of 1 is 0. This is log base 4 1/4 is -1. And I have log base b of y is equal to c. You may recall last year being exposed to a silly function that was either the Cossack function or McInerney function. That truly was called a logarithm. So I have it highlighted here. If log base b of x is y, that's true if b to the y equals x. If no subscript is given, that's called the common log, log, is implied the log base 10. It's called the common log. If you have a base of e, log base e of x, we use natural log ln x. Okay, it's not a 1, that's an ln x. So when you want to graph f of x equals the natural log of x, the domain is 0 to infinity, and the range is -infinity to infinity. There is a vertical asymptote. So some of us got that wrong on that one homework assignment. So be careful with that. So if I make a table, there is no number e to what power that I can get a 0. So we would say the y value is undefined. If I put 1 in, e to what power is 1, well, that's 0. And if I do 2, that's the natural log of 2. And so I've already graphed it. So the natural logarithm, written as ln x, is based on the number e, which is about 2.718, and is a crucial tool in calculus, as it's the inverse of the natural exponential function e to the x, which has a very unique property that the rate of change is equal to itself, which we'll save that for calculus. All right, in example A, the table below represents the function y equals log base 2x. So let's go ahead and plot this 4, 2, 2, 1, 1, 0. So here's that logarithm. There is a vertical asymptote. So in letter A, it says, what value of x would produce an output of -5? So you're thinking log base 2 of what? So that's really 2 to the -5. So it's 1/32. The domain is still 0 to infinity because I can't find 2 to some power that'll give me 0. Think about what's 2 to the 0 power. It's 1. However, my outputs can, in fact, be negative. They can be 0. How do the domain and range of this function relate to the domain and range of y equals 2 to the x? Well, for y equals 2 to the x, its domain is -infinity to infinity, and its range is 0 to infinity. So these two functions are inverses. So the domain and range switch. All right, then in example B, 2 to what power is 32? That's 5. 5 to what power is 5? That's 1. Now 36 to what power is 6? That's actually the square root of 36. So we would say the 1/2 power. Letter D, this is the common log. So 10 to what power is 1 over 100? That's -2. And this one, you're really asking yourself, e to what power is e to the third? It's 3. All right, so then what we're going to be doing in class is an auction. So it's going to be fun.